In this video, we are going to explore the ray model of light, how light interacts with various types of matter, and how we can actually see objects because of light. Once again, make sure you read through your learning goals before you go through the presentation, and as you go through the presentation to make sure you can accomplish the goals and the success criteria. So, we are studying a branch of physics called optics. Optics is basically just a study of light and how that light interacts with other matter and materials. We are specifically studying geometric optics, which is a study of how light reflects and bends. And so we'll see that in more detail during this presentation, what reflects and bends, what that actually means. To understand the behavior of light in optics, we use the ray model of light, where we represent light using an arrow, and that one arrow is called a light ray. So the arrow head represents the direction that the light's traveling in. The arrow tail represents the source from which the light's coming from. So we can see here that this light's coming from the light bulb and going towards the right of the screen. One thing that's very important to understand about light is that it travels in straight lines. And that's easily shown through this experiment here, where we line up 3 pieces of paper with holes in them. The holes have to be lined up perfectly. We have a candle, a light source on one side, and a viewer on the other side. The only way to actually see the light is if the 3 holes have lined up. If they have not, the viewer will not be able to see the light, because the light does not turn around corners, and it won't turn or go above the paper or below the paper. The light source will simply travel through the aligned holes to get into the viewer's eyes. So light does travel in straight lines, and that's an important concept to understand for the remainder of this unit. As I said, a single arrow in the ray model of light represents one light ray, but oftentimes objects will radiate or emit light, many light rays at a time. So as you can see from this lamp here, we have many light rays being radiated or emitted in different directions. Over here we have a flashlight, and coming out of the flashlight we have several light rays. What you'll notice that's a bit different is that the light rays coming out of the flashlight are all traveling in the same direction. So when you have many light rays moving in the same direction, we call that a beam of light. This over here is not a beam of light because the light rays are going in different directions. So there are many light rays, but they're going in different directions. You will often see beams of light in a flashlight or in lasers, and you'll hopefully have read your readings on lasers to understand what they are. So before we go into how light interacts with materials, I want to quickly discuss why you can actually see objects. And the big idea here is that to see an object, light from that object has to enter your eyes, and then it'll go through this series of nerves and connections to make its way to your brain so that you can actually make sense of what's coming towards you. So basically, to see this light bulb over here, light rays from the light bulb enter your eyes, and then your brain sees it as a light bulb. We connect the dots and make sense of it. Some magic happens that you'll learn about later on, but we make sense of it as a light bulb. So that makes sense for a light bulb. It produces its own light and sends it into your eyes. But as you know, there are some objects, like this dog and cat over here, that don't produce their own light. They're non-luminous. And unfortunately, we have a driver heading towards them. If they don't produce their own light to go into Barney's eye as a driver, how will Barney know they're there? Well, you guessed it. Light from a luminous object will hit the dog and cat. It'll reflect or bounce off the dog and cat and then go into Barney's eyes so that Barney can actually see it. They're there. So even if an object does not produce its own light, you can still see it because objects that do produce light will shine onto those non-luminous objects. That light will reflect off them and then go into your eyes. But the big idea here again is that in order to see an object, light has to hit that object, bounce off that object, and then go into your eyes, and your brain makes sense of it. Your brain connects the dots in the light rays in order to make sense of what's coming towards you. Here we can see rays of light coming from a light bulb. They're hitting a chair, they're bouncing off into a person's eyes, and that person can see the chair. You cannot see objects in darkness. Some students might argue, well, sure, sir, sometimes my room is dark and I can still see things. Well, yes, it might be dark, there might be low light conditions, but there's still light there. If you can see something, there's still a small amount of light bouncing onto some object and going into your eyes. But if you had complete darkness, so no light at all, you would not be able to see the objects that are there. It doesn't mean they're not there, you'll still bump into it, but you would not be able to see it because your brain, your eyes need light to do so. Now that you understand the concept of seeing things and how it relates to light rays, you're in a better position to understand invisibility. On the next slide, there'll be a link to a video that you can use, that you can watch, in order to understand how scientists can actually make some materials invisible by manipulating the way light travels. So now we're going to take a look at how light interacts with objects. There's three main behaviors that we're going to study for light. There's something called transmitted or transmission, reflected or reflection, and then absorbed or absorption. So when light hits something, three possible things can happen. It can be transmitted, it can be reflected, or it can be absorbed. There's a fourth possibility, that the combination of the three above concepts occurs. So transmission simply means that the light rays strike a surface and are transmitted, or in other words, go through that surface. Reflection, the light rays strike a surface and bounce off that surface. Absorption, the light rays hit a surface, the energy from the light rays is absorbed and then converted into heat, so the surface starts to feel hot. During transmission, sometimes what you might see is the light ray will go through a surface but bend as it goes through. In that case, we have transmission but also refraction. I'll go over each of these concepts in more depth on the next few slides. Here we see reflection, which is a process of basically light hitting a surface and bouncing off that surface. That is reflection. So here a lamp sheds light onto a surface, the light rays bounce off into this person's eyes here, and that person can see the surface. Reflection is what we're going to focus on for the first part of the unit. Reflection is the reason why mirrors work the way they do. So we're going to see how reflection and mirrors work together to allow you to see things within the mirror. And as you can see from this image here, we have reflection of light rays from an object into your eyes, which allows you to see something in the mirror. And we'll see that in more detail in the next few presentations. The other behavior, as I mentioned, is light can be absorbed. And when light is absorbed, it's usually converted into heat. Now, here's a perfect example of light absorption. You can see some light rays coming from a light source. So there's some light source here. Light rays are hitting the letter C. Many of the light rays that hit the letter C are actually absorbed. And those light rays that are absorbed, they don't make it to your eyes. The light rays that hit the blue part over here, they actually bounce off and make it to your eyes, and so you see all the blue. Any part where there was this black ink here, light rays do not bounce off them, so you don't see any blue there. So what you actually see is well, missing light. You're not really seeing anything here. You're seeing all the light rays hitting the blue part, and so you're seeing the blue because the blue part reflects into your eyes. And then wherever there's black ink, well, that's absorbing all the light rays. And so what you're noticing is, there's nothing bouncing off that area there. So it's like there's a little hole created where there's no light bouncing off of it. And so your brain will interpret the absence of light as black. Something that is colored black absorbs light and does not reflect it into your eyes. So when you're looking at this PowerPoint screen, actually, the overall slide itself, all the white around the slide, that's reflecting a whole bunch of light rays. In fact, all the colors of light, and you can see that. But this black part here is absorbing all the light rays. So you're seeing a portion on the screen where light rays are just being absorbed. What your eyes are basically creating here, or your brain's basically creating, is a cutout where light is being absorbed and not reflected. This, by the way, should say absorption, not adsorption. Another behavior, like I said, is transmission, where light will strike a surface and continue going through it. So for example, if you look through this piece of glass, what happens is light strikes it and just keeps going through it on the other side. And usually if light is transmitted through an object very well, then you can typically see through that object. So based on the idea of transmission, reflection, and absorption, you can have different optical properties of matter, meaning you can see very well through some matter, and through others you can't see through so well. So over here, if you have an object that's transparent, what that means is light can be transmitted through it freely, quite well. On the opposite end, or on the other end of the spectrum, you have opaque objects. They don't transmit any light at all. They basically reflect or absorb most of their light, and because of that, you cannot see through those objects. So if you just hold the book up, like a textbook, your science textbook, all the light rays are reflected or absorbed by it, and as a result, you cannot see through it. In between, another type of another type of matter is translucent matter, which does let some light through, but not as much as a transparent object. So you don't really see too clearly through it. You can see through it, but not very clearly. So for example, you might just see the silhouette of a person. If you take a look at wax paper during your lab, you'll notice you can see through it, but not 100%. You only see the silhouette of the person, or you might just see a blurry image because not all the light rays are going through it like you would see in the transparent material. So here we have our summary of absorption, reflection, and transmission. You can see over here in this part of the image that if all the colors of light are reflected into your eyes, you will actually see that surface as white. If all the colors of light are absorbed by the surface, that would be the absence of light. You'll see that surface as black. And if all the colors of light go through freely or are transmitted, then you can see through the surface. And again, the degree to which materials will transmit, reflect, absorb determines whether they're going to be transparent, translucent, or opaque. So I did mention that light can be transmitted. It can go straight through an object. But sometimes when it's transmitted, in addition to being transmitted, it'll also bend. And that bending, as you can see here, that is called refraction. So light can be refracted. So we actually saw this. We actually saw an example of this, or spoke of an example of this earlier, when light from the sun goes through raindrops. The different colors of white light will actually transmit through the raindrops, and as they go through the raindrops, they'll bend, and since they bend away from each other, the colors of light separate, and we can actually see the rainbow. This concept of separating the colors of light using refraction is called dispersion. Dispersion meaning separation. And so that's what allows us to see all the colors of white light because of that bending or refraction that happens. And that will relate to concepts that we study later on, such as lenses, Snell's law, total internal reflection, and other applications like glasses. So, like I said, sometimes a combination of all of those behaviors can occur. Here we can see a picture of that occurring. We see some light rays are being reflected over here. We can see that some of the light rays are being absorbed and maybe converted into heat. Some light rays are transmitted, and sometimes you might see bending along with that transmission or refraction along with that transmission. So a combination can occur as well. Another behavior that we will see, but not too much detail, you'll see it more in grade 11, 12, is a concept called diffraction. And that's actually how these diffraction glasses work. Basically, light waves will spread out as they go through a very small opening. So you can see light waves traveling through this small opening. Because the opening is small, it causes the light rays to bend and then sort of spring and spread out as they go through that small opening. And that's exactly how these glasses work. There's these very, very small slits in the where your eyes would be, and that causes the diffraction. And that diffraction basically allows you to see rainbows when you put these glasses on. Sometimes you'll see the same effect when you're looking at the back of a CD, where the light appears to bend when it goes around small obstacles on the CD. So this is a summary of all the different behaviors that we studied. We're going to see transmission, reflection, refraction, and absorption in detail. There are other behaviors of light, such as diffraction, which really I just want you to know that the glasses that we used in class work that way. And there's also scattering, where it's really a type of reflection, but it's reflection in all different directions. So you should do your readings, page 479 to 481, answer the questions on 41, number 1 to 6, and complete all worksheets. This here is an image of a concept that we will study in more detail later on, but if you really want to know, I encourage you to read ahead to try to figure out what this is a demonstration of, or when we do cover it in class, you should come back here and write down what this is a demonstration of.